Hey guys, Mr. Vree here. We're going to do a video here on standard error of the mean. Standard error of the mean is one of the most useful statistical tools in biology because, as you know, we use averages a lot. We use the mean a lot. But standard error of the mean really allows you to have a degree of confidence in how accurate your mean is. And so what I've put together here is two different data sets. So we have data set number 1, which has just two samples, 9 and 15, and data set 2 has 10 samples. And so let's take a look and see what these means come out to be. So if we do equals average, you can see data set 1 comes out at 12. And data set 2 comes out at 12. So when we want to calculate the standard error of our means, what we need to do is use this formula over here. So standard error of x bar, which is the mean, is equal to the standard deviation divided by the square root of n, where n is the number of samples in our set, the number of averages that we have. And so you can imagine that if n is a large number, then it's going to produce a number here that is larger, and it's going to divide in the standard deviation. If n is larger, then you're going to get a smaller standard error. So having a large amount of samples is going to reduce your standard error. And so let's first do the standard deviations. And so you can see right away we have a pretty large standard deviation for data set 1 because, I mean, look, we have 9 and 15 and the average is 12. So it's not a great deal of accuracy. And so standard deviation is very much related to standard error. But it's not the same thing. And so in order to get the standard error of the mean, I'm going to do set 1 first for you, and then you're going to calculate set 2. So if we do the standard deviation, 4.24 divided by the square root, so SQRT, and we have square root of n, and so we have two samples in set 1, 9 and 15. So the square root of 2, and so we have a standard error of the mean of 3. And so I'm going to pause the video. I want you to pause the video now and calculate the standard error for set 2. Ready? Pause. Okay, now I'm going to do it on the spreadsheet. And so hopefully you used the square root of 10, since there were 10 in the sample for set 2, and you got an answer of 0.27. Okay, so what we really want to look though is at two standard errors of the mean. And so all you do is take the standard error of the mean and you multiply it times 2. So in this case, two standard errors of the mean in set 1 would be 6, and two standard errors of the mean in set 2 would be 0.54. And what that is telling us is that we can be 95% confident that the average for set 1 is plus or minus 6 away from 12. So all the way up to 18, all the way down to 6. That's a huge range. And so in order, you can't be very confident with set 1. Whereas set 2, you can see how tightly grouped all of these values are. And so we get a pretty small standard error of the mean. It's only going to be plus or minus 0.54. So let's make a bar graph of this, and what we'll do is we're going to insert error bars into our graph. So what you want to do is you want to highlight mean, 12, and both the averages, and then come over and hit the insert chart button. Alright, I had to pause the video there for a second. It wasn't showing up quite the way I wanted it to. So I'm going to try something different here. I just moved the data over, and let's see if I can do it the other way. I want that set to show up if I want the title. Could always add it. So we want a column chart. And if we switch the columns and the rows, if I click that checkbox, then I get them to be two separate bars. And that's important if we want to put in different error bars for these. And so what we want to do is we want to customize our graph now. And we could add titles to these. We could change it. We could add the mean of whatever. Probably would be a good idea to also include that the bars are showing with two standard errors of the mean, so they know what the error bars are. Now if you go to series here, we see how if they have a checkbox for error bars, and we want to have two, and so our error bars are showing up here, but we want to have separate ones. So if we go up to apply to, that's why it's important we have two different colors here, so we can distinguish each set with its own set of error bars. We want a constant error bar, and now we're going to insert for set 1 a value of 6. In set 2, we're going to insert a value of 0.54. Okay, so obviously these bars are going to overlap. So we really can't say that set 1 is any different than set 2. But if these bars are overlapping, if they're not overlapping, we can say that with 95% confidence, and this is the important part, then they are significantly different. So I put together another data set here on a different sheet, and so we have two different data sets, and I've done all the mathematics for you. And so you can see this one has a mean, set 1 in blue, of 3.61, and the other one has a different mean of 7.87. But how can we really confidently say that one is definitely different than the other? Well, we can say with 95% confidence if the two standard error of the mean error bars do not overlap. And I guarantee this will be a test question on your test and on the AP exam. And so when I set up my graph, you can see I made error bars of 0.88 for set 1 and 0.64 for set 2. You can see how these bars are not overlapping. And so that means that we can say with 95% confidence interval that these means are statistically significantly different. So that is standard error of the mean. I hope this was helpful.